Hi, everybody. I've got 11:55, so we're a couple minutes early. I'll probably just start talking and then we'll officially start the program at 12 o'clock in 5 minutes. And then about 12:02 or 3, we'll turn it over to Sigmetrix. And I see that they're on, so we're good to go. So that's good. Looks like we only have about 26 people registered, even though I did advertise it on PTC user and my own Badgerland Facebook group and LinkedIn groups. So don't know if this isn't a popular subject or just don't know, but yeah, it'd be nice if we had more than 25 people, and maybe we do have some people signing up late, which is fine. So I'm going to share my screen 2, share. And here it is. And if you've been on these lunch and learns in the past, this is very familiar. So I'll just go through it real quick and feel free to speak if you have questions. So yes, we're a user group. Here's some Milwaukee scenes in the fall. Welcome to our Milwaukee Badgerland User Group virtual lunch and learn. We do have some people in Wisconsin outside Milwaukee, and welcome. So as I said, Sigmetrix will be leading this off about 12:03. Everybody should be muted upon entry. Stay muted unless the presenter asks for questions. I'll try to monitor the chat, and this will be recorded. Last time we had a little glitch and it didn't get recorded, but every other one for the last year and a half has successfully been recorded. We post it on our website, BadgerUG.com. We also post the recording on our Facebook group and LinkedIn group. So, and I've got my contact information. If you can't get to the recording either way there, I can always send it to you. So just reach out. So yeah, Badgerland User Group was established in 1994. We've had 3 meetings a year ever since then, except the last year and a half. And we average about 100 attendees. It's a full day meeting, breakfast, lunch, and door prizes in the Milwaukee and Kohler area. These are some of our sponsors. Today is Sigmetrix. TriStar is coming up December 10th. We'll post more information about that. We'll try to get somebody for November, but so far I don't have anybody for November, but there's still time. So this is our area of Wisconsin, Green Bay to Madison to Milwaukee to Chicago. Most of the people that attend these meetings are Milwaukee people with suburban Milwaukee. We do have membership dues, fees. Since we're just having virtual meetings, I think this year we reduced that by 50%. These have been our typical meeting venues. Manpower downtown, we get that whole center. And then Blue Harbor, we try to go there every summer, but the last 2 years we've had to cancel. So this is my contact information. LinkedIn, if you want to reach out to be a connection on LinkedIn. Sometimes I do get people contacting me about, looking for people for different jobs. So if you're looking for work, go ahead and contact me, and then I'll just, pass your name on to somebody if I get contacted. Here's our website, BadgerUG.com, our Facebook and LinkedIn groups. Just go to LinkedIn, search for groups, type in Badgerland User Group, and we'll see that request and approve you. So yeah, December 10th, lunch and learn star. This is what tentatively we're going to be talking about, or what they're going to be talking about, are Creo extensions that used to cost money, but they're now included with basic Creo. And Thiago we think will be speaking. And so it's a lot of content, and they'll go through it quickly, but it should open your eyes to what other stuff is out there that you don't know about, that you haven't been able to use yet, or unless you already have purchased those extensions. PTC LiveWorks in 2022 will be virtual again. PTC User is having a convention October 3rd to the 6th, so a year from now in Orlando. And there is a new website for PTC User. You have to create a new login. We got 12 o'clock. One other thing here is this month, October 29, we've got our BadgerUG Group Admin Roundtable on Zoom, Friday at 11 a.m. And this is for people who are Creo or Windchill administrators. And it's just sort of a roundtable. There's no agenda. It's to ask people in similar roles questions and have each other help each other. And that group has expanded from 5 or 10 to maybe 10 to 15. We're getting some people joining from Arizona, aerospace type companies. So that's about all I've got. I've got 12:01. If anybody's got a question, let me know. Otherwise, I will stop sharing and turn it over to Sigmetrix. Thanks to Sigmetrix. They've actually spoken a couple times this year, and we appreciate it. And so I will stop sharing and then mute myself. And is Sigmetrix ready to speak?
Yeah, absolutely.
Cool. Welcome. Thank you.
No problem. Thanks for the kind introduction, Deb. I appreciate it. Let me get my screen pulled up here for you guys real quick, and then we can get this show on the road. Can you guys see everything okay?
Yeah.
Great. Fantastic. So as Deb said, my name is Ross Snyder. I am a application engineer here with Sigmetrix. Today, what we're going to be doing is we're going to be going over our tool, the GD&T Advisor. It's a tool that works with Creo, and what we'd like to do is showcase some of the updates that we've made for Creo 8 in particular. And also what I'm probably going to run through first is I'll give some of you guys a little bit of a introductory crash course, a little bit in the basics for the software, just in case anybody hasn't seen it before. And then what we'll do is we'll dive into a couple of specific examples that'll help me walk through some of our features that have changed since our last release. And then after that, if you guys have any questions, we'd be happy to open the floor and ask for it. My boss will be Stephen will be on the call as well to help us field any technical questions that we arrive with as well. So with that, let's get started. So what we're looking at here is a model that we like using for some of our different demos. So if you've interacted with Sigmetrix in the past or seen some of the posts that we've made online places, you might recognize it. So this is just a caster wheel. Kind of like you'd see on a push cart or something like that. It's nice and simple. But what I wanted to do is just show you guys the full model here before we dove into some of the parts that we're going to be interacting with. So you can kind of grasp why we're doing what we're doing based on what the utility of the model is. So for instance, one of the main parts that we're going to be working with is the support arm here, and you can see that we've got a pressed in bearing and we've got an axle it's got a support and it's bolted in with M10s, things like that. So with that, what I'll go ahead and do is jump into just a quick run through on our GD&T Advisor tool in general. So we've got Creo 8 open up here, and of course my little Zoom window is hiding what I need to see. So here, one second, there we go. Up in the Applications tab, you can pull up our GD&T Advisor tab. Now, as a quick walkthrough for what you kind of see once you turn that tool on, up here you can see that we've gotten an additional toolbar. This is where we're going to be pulling all of our commands in for the GD&T Advisor. Down here, we've got our feature tree. As we start adding our different callouts for GD&T annotations, they will start populating here within this feature tree. And it will look very similar to a model tree you would see in a Creo design space, or if you're familiar with, SolidWorks or any other modeling tool, it'll be similar to that. Down here is our advisor tree. So this is going to populate similarly to the feature tree, but this will all be information based on feedback from GD&T advisor. So information like what we're seeing now, that not all of our degrees of freedom have been constrained yet, or that we have not constrained certain surfaces of the model. Any errors or informational messages will also pop up here. This is the section of the tool that will guide us through the process of making sure that our GD&T calls are accurate, which is part of the reason why using GD&T Advisor to add annotations in your model makes things kind of quick and easy and painless. Looking into our main window here, we've got our part, or later our assembly that we'll be working with here in the model. And then down here brings us to one of the first feature updates that we've brought in for our latest release. So down here in the window, you can see that our standards are listed, are ASME 14.5 and 14.4, 2009 and 12 respectively. One of the things that we added into our latest release was being able to adjust this information based on what standards you're trying to get your GD&T to adhere to. So if we go up here into the Creo file menu and go up into prepare and model properties, you can scroll down here and actually change, if we're looking at, bring this back over here, whether we're looking at ANSI or ASME or ISO standards. Something else that you can adjust as well is we've introduced the 2018 standards. So you can bring that in and select these standards for the tool that you're trying to adhere to with the when you're putting in these annotations. Next, what we'll go ahead and do is I am just going to walk through a brief example of just getting some of our GD&T callouts placed on this model with the tool here. So we saw in the overall 3D image where this part fit into the caster wheel. We've got a mating surface up here and a couple of fastener holes, and this is where our bushing is going to be pressed into place. And with that, we're going to have to call these out and make sure that we control these with our GD&T. So if we go up here to tolerance feature, we can start doing that. So we'll go ahead and select that top surface and hit accept. And that will adjust this toolbar up here to give us our options for how we're going to be building our GD&T callout. Now, to start with, we can rename these. We can adjust whether or not we're trying to do a tolerance callout or just a sizing dimension. Over in this drop down here, you can see that we're able to select what kind of a GD&T callout are we using: straightness, flatness, circularity, things of that nature, perpendicularity. But all of these are grayed out except for a couple of different options. There's a good reason for that. So the GD&T advisor is helping guide you into making the right decision for the kind of callout that you need to make for this particular application. And because we have no existing annotations that we're basing things off of, flat surface over here, it's recommending either flatness or profile of a surface. So these are both highlighted green to suggest that they're a good option for making this particular annotation. Now you can see there's a little asterisk right here. The software will give you a strongest recommendation. That's what's going on here. So we'll go ahead and stick with those recommendations. And just for simplicity, we'll be keeping the tolerances fairly basic on this, just 0.1. Over here, you can see that it's automatically assumed, because this is the first callout that we're going to be making on the part, that it is going to be our datum A. As we go through and we add more GD&T annotations, we can actually deselect this and decide that these particular features that we're adding are not going to be datums, or it'll pick up after A, B, and C are listed. That you can add a datum if you want to, but the option is also available to be turned off. So with that, we've ticked all the boxes for our requirements for the tool, and now we can hit the green check mark, and that drops that right in there, and it'll bring our standard in, or our annotation in, based on these standards that we have selected. So let's go through and continue adding our various annotations that we need in here. And so we'll go ahead and drop in our tolerance for this. And again, you can see with this drop down, we've got some new options that have popped up for us. But it's still making a recommendation of perpendicular angularity. We're going to go with perpendicularity, but the software will also help you explain why shouldn't I use some of these other options that are available to us. So if we highlight over these, you can see, like, for instance, circularity, it will result in an under constrained feature. Or if we're trying to do a run out, that's not compatible with the current DRFs that we're using right now. So our data reference frames. So we'll go ahead and stick with perpendicularity, and we'll leave this over here as a regardless feature size. But this is an area where we can add our maximum material condition or least material condition callout as well. We can also adjust what DRF that we're trying to reference, but it automatically assumes, based on what we have available to us, which one that we'd like to reference for this particular callout. And we do want this to be our datum B, so we can leave that alone and we can move forward. And so now that we've got that callout, let's go ahead and do the same for the other hull. And we'll leave that alone, put that in as 0.1, leave this here as RFS, and that's going to be our datum C. Now, you can see that as we're progressing through here, while our two notices that we originally started with, that our degrees of freedom are not fully constrained yet, and that some surfaces are in the design model are not constrained, they're still there. We're still working towards making sure that our degrees of freedom fully take care of that. But if you pay attention down here as we go through and add more of our datum references, you can see that it's letting us know that that new AB datum reference that we just added is not being used by anything. It's just a little blue dot. It's letting us know informationally that that's a thing, but that'll update and change as we start adding things. So for instance, as we drop this in here, you can see that that is now changed to the ABC DRF is not being referenced, but because we got our 3 datums in there and they are sufficient to take care of our degrees of freedom, that notice has gone away for us to take care of in the advisor tree. Now, on the top here, we know that, okay, those 2 bolt holes and our mating surface, they're all taken care of, but we have a couple of other critical features, namely the area where we're going to be pressing that bearing in, or that bushing in rather, and the surface that's going to end up mating up to. So let's go ahead and get those taken care of. Go ahead and start with our hole for our bushing, and we can put that in as 0.1 and here. And then something else that we can also do, if you're looking to further control your data reference frame, you can actually add segments for this in with this drop down here. Or if you bump it on accident, you can pull them back out by using this. But it will also make recommendations based on what you're looking for, just as the other windows have. So let's stick with parallelism for a second, and we're going to put this as a 0.2 this time, and I'll show you guys something cool. So if we go ahead and we click in here, we can see that, we got a little bit of an error message going on. Now, as we add these different annotations, despite the fact that we're selecting from different things that are recommended to us with the tool, if we do punch in anything that's incorrect, the software is going to start popping errors up to let us know what we need to be looking for. So down here, you can see that it's telling us that the orientation tolerance must be smaller than location tolerance. Well, I don't know which one you're talking about. So if we click on it, it'll highlight which callout that we just did. And that is the stacked callout down here that we just dropped in. So if we go back and edit that last annotation that we put in here, what we can see is, oh yeah, I forgot. This has to be less than this. So if we make that a 0.02, for instance, and hit OK, that's still not fixing it. We need to make sure that when we click off on these, that our feature here, 0.02, there we go. Great, hit OK. And as we correct those, then those errors will go away. And so we can tick through and make sure that while we're adding all these different annotations, that we're keeping things correct and we're not over constraining or adding incorrect callouts to anything based on the standards that we've selected in the beginning of setting this up. So now that we've added those, and we can add our last surface feature down here, we'll hit accept, drop in that 0.1. We've got all of our reference features referenced up in here, and we can see that it wants us to use profile of a surface. That's what we'd like to use anyway. We do not need an additional datum for anything, and we can go ahead and hit OK on that. Now, we know from a manufacturing standpoint that we've added all of the controls that we need for the important surfaces that are inside our part. However, we're still getting this message here that's telling us that some of the surfaces aren't constrained. Now, if we want to take care of that, one tool that we have at our disposal is this show and hide constraint state feature. If we click on this, you'll notice that it paints the part up in a couple places in a bunch of cool colors. And what it'll let you know down here with the legend is that all of those things that you just interacted with, those are fully constrained. Or if you missed constraining something and it's partially constrained, it'll highlight that as well. But we can see that while all of our critical features have been constrained, the rest of the part is not constrained. Well, while those aren't super necessary for what we've got going on here, it'd be nice to control those just for the sake of manufacturing for our particular situation. So we can do that with a general surface callout, which can be added from properties. So if we go up here and we jump into properties and notes, we can add a general profile tolerance to our part. And if we click on that profile tolerance, we can add in the tolerance that we'd like to add to that and hit OK. And now we can see that by jumping in and doing that, all of the different surfaces of this part have now been fully constrained. We're good to go there. And you can see that that notation that we had an issue over here in the advisor tree has been taken care of. So that's kind of the basics of walking through just adding some tolerance dimensions to your part here. Next, I'd like to jump in and open up another part that I've got that I've aptly named our problem plate. So if you're working with parts that come with partial annotation or existing annotation, one of the things that you can do is you can run the GD&T advisor and make sure that those annotations are correct and interact with those in case they aren't correct. So if we go back up here and we boot up GD&T advisor in this window, you'll see the beginnings of one of our features that we've added again to our Creo 8 release of our GD&T advisor. So this window is going to let you right out the gate decide, okay, well, I've only got a few annotations. I'm just going to blast these away and start from scratch. So that is an option here. Or if you'd like, it will also run through and validate all of your existing GD&T annotations that are on the part and let you know if there's any issues. So we'll go ahead and hit validate all, let that run for a second and think about it. And once we've done that, we can see that, man, that populated all that same information right here in our tree for us, and with all the details for the different callouts. And everything looks to be mostly on the up and up, except for we've got a couple of issues that have popped up in here. So let's take a look at those and see what's going on. So to start with, we can see that the 0 value tolerance is not allowed. Now, this is a pretty minimal call out. It's kind of, it can be a little up in the air. Just an example of where as you've selected which particular set of standards that you're trying to adhere to, the GD&T advisor will go through and analyze the existing annotations and make sure that they are up to those standards. And if there's any inconsistencies or inaccuracies based on those standards, it'll flag them so that you can fix them. So let's go ahead and get that fixed. But let's say that we're a little bit new to adding our GD&T callouts and we're not as familiar with what it's trying to tell us here. If we go into the help menu and pull that up with a right click, not only will it define what it's trying to tell us, but it'll also let us know why and to what standard that this conflicts with. So you can see here that it's telling us that based on that 1441 standard that we've got selected, we're supposed to have a tolerance on a dimension and not leave it at nominal. So if we pop back over here, and we can see that by clicking on it, it's highlighted that particular dimension that we've got here and the callout that it's connected to. We can go ahead and just edit that dimension's diameter and see that, yep, it's sure right. We've got that selected as nominal, and we need to put a tolerance on that. So if we hit this drop down, we can edit what kind of callout that we've got on here and just throw our regular symmetric tolerance on. If we hit accept, we can see that, boom, that problem's been taken care of and we can move on. And you know, that just one example of how it highlights you through the process. Now, this other notification that we're getting from our advisor tree here, this is telling us that we've got an annotation mismatch here. And so this is where another one of the features that we've adjusted more so than added for the new release comes into play. So if we go up here to manage annotations, we can take care of this mismatch that we've got listed. Now, this used to be taken care of automatically when we validated all of the existing annotations. But because that moves really quick and you could see that little window was just popping through things real fast and then disappeared, and I don't know what it checked, I don't know what it fixed. We slowed the process down a little bit so it was a little bit more clear for the users. And now, other than just checking off that, yep, these are okay, if there's any sort of mismatches that you need to address directly, it gives you the option and lists off what's going on right here in the manage annotation windows. Also, if you come back after you've added additional annotations that haven't been validated, it'll let you know if there's any additional annotations that you need to add to validate through that process as well. And you can refresh that and either delete them or validate those that way. But for here, we can see that on that same callout that was our little problem child earlier, you can see that it's giving us a shape modifier required. So I thought when I put that in, that looked great. You know, it's got what I thought it needed for all the information. It went in there fine. It looks like it's complete. I'm not sure what's going on. Well, if we tick that box, the GD&T advisor will actually correct this issue for us, and we can hit update. And now we know that that annotation is what we were updating. Oh, you know what? We missed that diameter call out that was in that particular reference frame. So now that's been taken care of, and we can see that our error has gone away, and we don't have any more annotations that need managing, and so that's been grayed out as well. And so from there, now we're good to go on this plate. We've checked all of the annotations that we put in Creo, and we don't need to mess around with any of these. We can be confident that these all adhere to the standards that we've selected, again, down here. So next, let's jump into one of the most asked about features that we've added into. Lost my headset for a second there. One of the asked about features that we've got here, and that is working with our assemblies. So if we go ahead and pull this up here, this is an assembly that I've put together that is a little bit different than how we usually handle the caster wheel. And so what we've got going on here is I have pressed this bushing in, but let's go with the assumption that this bushing hole is so critical that we have to drill this in place in position after we've pressed this in place. So working with the GD&T advisor with an assembly, what we can see is, how this treats this is basically a inseparable assembly. So these have been permanently affixed to each other, and that's how it will treat things going forward. This being press fit into here, good example of that. So what I'm going to do now is run through just basically the same process that we ran through on this part without the bushing, and we're going to throw some of our annotations on here, and we'll get that moving. But now we can do this in an assembly state. So let's go ahead and boot up our GD&T advisor here and start tolerancing our part. So if we go ahead, we can add our top plate like we did last time for datum A. Hit OK. Now, this brings me to another option for us here. So we know that our datum B and C are supposed to be those holes. So if we selected those and we put in our tolerance and we make sure that we are using this as a tolerance callout instead of a basic dimension callout here, we can see that, oh, we've got this red tab pulled up right here. Now, if we click on that to figure out why it's not letting us progress forward and add that datum B, we can see that, oh, shoot, we need that actual diameter callout in order to reference that for this particular annotation. Now, before, what you used to have to do is go, oh, shoot, that's right, I needed to add that. You had to close out a GD&T advisor, go over to your annotation window, and then correct the issue and add that stuff in there. We've tried to make this a little easier for you guys now, and what we've added is you don't have to do anything. You can just pop over here to annotate real quick, make sure that you're on the right annotation plane, and you can go ahead and select these particular callouts right here And let me double click that because we want that in a diameter and drop this in. And we can drop those dimensional callouts that we need in right here. And I know we're going to do this on the other hole as well. So let's go ahead and do that while we're here. And we can pop right back over to adding that tolerance in without having to reboot or click a bunch of toolbars to get back to where we needed to go. Now, something I will give you guys a little bit of a teaser of right now, and I did run this by development where they did promise me that it was on the list. So there is, on the next release that we're working on, going to be an option to automatically generate those right from here, instead of having to, even as simply as it was, just to make things a little bit easier for you guys. So now one of the things we can do here is we can use this auto match button, and we can actually click this, and it'll find that tolerance that we put in right here, or I'm sorry, that diameter dimension that we put in, and reference it right away. And you can see that our check mark turned green and we're good to go. So we'll hit OK on that. We've got that particular call out. We'll do the same for the other one. Now, because we added that dimension, we don't need to redefine that dimension. It's already automatically found that it exists. So that's not pink, and that's why we don't have to dive into doing this a second time. But, much like the last time, we've got the different requirements or recommendations that we've got over here in our dropdowns. Everything is interacting fairly similar to how we interact with the parts. The only thing that we do need to pay attention to is as we populate this, something it won't start. The errors that are going to start popping up in here are going to be a little bit less than they would be if you were to be working with just an individual part. So part of the reason for that is a lot of the assumption for working with this at an assembly level is that these are fully dimensioned at the part level. So when you do that, those are available, and these are typically for assembly reference. You need them for a particular sort of inspection after assembly, in the case of, our press fit before we drill, things like that. And we can see, though, that it is still checking for things like our zero tolerance issue that we had last time. So we can go through and we can correct those to our symmetric tolerances, and we can run through and do that for this one as well before we move on and add those. Great. And we can see here that we have another call out that our value exceeds our maximum tolerance value because we made a typo, and that's supposed to be a 0.1, not a 1. And so as we work through, you can see that we've only added our A, B, and C tolerances, or our datums, and so we've got our degrees of freedom controlled, but we don't have any other notices that the part's under constrained, that it is missing certain definitions for certain surfaces, because the software understands that we're working at an assembly level. So let's go ahead and we'll go ahead and throw on just our surface call out here for our bushing, a 0.1, because we learned our lesson from last time. And we'll go ahead and tolerance that hole that we're going to use as a pilot hole for further drilling that out in the correct spot later. And we can see that that has also automatically generated things, does not require an additional datum. It just makes this really quick and easy. And so with that, the only other thing that I will note that if you have to do any sort of call out for a regular dimension instead of a tolerancing dimension, you can set those as references here as well, because reference dimensions are acceptable at the assembly level. And with that, that is the overview of our brief demo. We basically our new features, they're a little bit here and there. We kind of tried to pay attention to the feedback we got and everything, but that'll give you guys a good indication of bigger updates, like working with assemblies, and smaller updates like not zooming through all of your validation. With that, Deb, that concludes my portion of the actual presentation stuff. I'd like to open it up. If any of you guys have any questions, myself and Stephen would be happy to floor them.
Yeah, anybody go ahead. We've got this opportunity to ask questions. So is anybody ready to speak? So I see something in the, oops, sorry, chat. Chad, or sorry, Russ, can you see that chat on the problem part that had the 8 mm hole without a tolerance? Would a general tolerance note giving tolerance values based on number of decimal places more common with inch values satisfy this particular conflict?
On the problem part that has the 8 mm hole without a tolerance. I so to answer that question, I don't believe that just by adding more tolerant or more decimal places to that particular call, it would fix that particular justification. Just because it was asking for an actual tolerance value, and when we went to correct it, we didn't change a tolerance. We actually added one.
So the way that I read this is lots of times companies have in the title block, you know, there's 1 decimal point, it's this and this tolerance, 2 decimal points, this and this tolerance, but that's not something that that this can see. Is that correct? That, you know, the GD&T advisor can see or that type of tolerance block note.
So the tolerances that it'll pick up on in here are annotations that you've added in the actual software, and it'll bring that in. But conversely, if you don't have anything, or you'd like to redo them or add additional tolerances, these annotations will immediately be saved to your Creo file. It is an authoring additional tool for you.
So if I could add a little bit of detail to this, this is actually an area. So GD&T Advisor is really is focused on accurate model-based definition. And so the concept of a generalized tolerance in the world of MBD is still somewhat gray right now. In fact, I've heard it discussed at different events in terms of an area where the standards needs to make some progress. And there's debate on what's the appropriate approach. And we've talked about having the general profile note as an example, if you added it, be automatically associated with any surface that doesn't have an annotation associated with it. But then the question is, well, is that otherwise specified or not? There's a lot of discussion to be had. The point I want to get, though, is that if you want to rely on your drawing block tolerances to control the tolerances of a specific value, a specific dimension, then these messages that you're seeing are just information for the user to understand that this particular dimension doesn't have a tolerance. Now, yes, GD&T Advisor calls it I think a warning, but it doesn't know that there's going to necessarily be a drawing created from this, and you as the user do, right? So this just information that's presented to the user. You don't necessarily have to resolve all warnings before you release a drawing. It's just to help you understand that this situation exists, and you make the conscious decision at that point to go ahead and show this particular dimension on the drawing, have block tolerances apply, and everything's fine.
I have a question about, of course, in this particular case, it's set to ASME Y14.5-2009, and by the way, it looks very good. It does an excellent job of validation. Does the validation state from GD&T Advisor, is it stored in the Creo native file as valid or invalid? And maybe this is a question beyond GD&T Advisor. Is that validation state of that MBD GD&T stored in and exported AP242?
It any flag, if you're talking about a validation state flag, is not stored. We save all this information, obviously, and anybody that opens the file up and looks at this data with GD&T Advisor can see it. But the only thing I would say that we're creating within the native Creo file are the annotations themselves, notes, things like that.
Okay, so a valid Creo file can exist, but I don't have a way of a downstream application to know that it's been validated according to GD&T Advisor, which is very valuable, I think, for many customers.
Not today. I mean, no, not today.
Okay, thank you.
Sure. And similar to that, because we get the question often times, right now that doesn't have any interaction with the model check directly. We haven't done anything to integrate within that checking tool.
All right, thank you.
Mm-hmm.
Anybody else have any other questions for us to floor?
Just wondering about a freebie test license. Does something like that exist for a short amount of time?
Stephen or Kyle might be able to answer that question a little better than I can.
So yeah, my name's Kyle Hightower. I'm the one of the account managers for Sigmetrix, and that can be done, but usually it is direct through your PTC reseller. So Sigmetrix obviously develops the software and supports all of the training needs for this tool, as well as the 1D tolerance analysis tool. But the majority of a actual kind of freebie or sales cycle is direct through your PTC channel bar. And real quickly, as you know, we are taking questions. You know, I did want to point out. So Sigmetrix, we help others make better products through mechanical variation management, and these are our 5 business value points that we are able to help companies, maybe 1, maybe 2, maybe all of them together, in these specific areas of their businesses. Obviously, today we're talking more on the model-based definition aspect, but they're all loosely connected. So as we're continuing discussions down the line, or if you see something here of a potential pain point, Sigmetrix would most likely be able to help you out with that, either directly or through our partners like PTC. So any other questions or on that, or potential training, like I had mentioned, for the software?
I'm just wondering, anybody on the call, do you currently have the GD&T Advisor or at your company or no?
Yeah, we do. It's a very useful tool.
Glad to hear that.
Larry, I'm going to quote you on that.
You can.
It's been recorded. There's evidence.
No, I seriously though appreciate that, and some of the downstream effects of doing this. There's a lot of big benefits of it. One direct from Sigmetrix is either of our tolerance analysis tools are able to import these model-based definitions. We can really speed up and make the tolerance stacks, whether it's a 1D or a 3D, so much quicker and efficient. So beyond just the immediate effects of what you're seeing here, there is a lot of larger impacts throughout the whole life cycle of your model and processes.
The idea of trying to bring the process of making these annotations easier for multiple different users. You don't have to rely on 1 or 2 GD&T experts in the office in order to supply this accurate information, whether it's used immediately or downstream, is a real value. And as as we're showcasing a couple of the updates we've got, because a lot of you, as mentioned, have either seen or at least used our software before. It's nice to get it in at this level because it can be very beneficial downstream.
That was a gist of my question. Knowing that a model was Sigmetrix validated is important to downstream metrology consumption.
Absolutely. Being able to depend on your GD&T annotations, knowing that they've been compared to whatever standard you're trying to adhere to, then you can rely on the data. And then if you've got to change something, it's got to be an actual change, and it's not, somebody fudged some numbers real quick or something.
And I can definitely attest to the amount of times we've had previous or new customers come to us with manufacturing, requests / trying to settle an argument of, hey, well, what is actually going on, with this print, with this model, like how is this being manufactured? We're having, inconsistencies. And the more that this is done and understood through correct GD&T application, and sometimes training is required for that, that just solves so many questions and problems down the road. So, and arguments.
Absolutely. Well, if nobody has any other questions, I think that concludes our presentation for today. Just wanted to take a minute and thank you guys all very much for your time. Obviously, this has been recorded for your guys' benefit, but if you're stewing on the information you saw today and you've got a couple extra questions, myself, Stephen, and Kyle, in addition to a number of other resources we have at Sigmetrix, but are all available to be reached at to help answer questions. We can get on calls or even give you a private run through on some of the specifics if you've got questions on anything you saw here today.
Thank you, everybody.
So much. Thanks, Ross. And like I said, this should be recorded in about 20 or 30 minutes. I'll post it to our Facebook and LinkedIn groups. And then probably over the weekend, it'll get updated, sent to our BadgerUG website. So
fantastic.
Guys,
Thanks,
have a great
everybody.
afternoon.
Thank you.